How far are we from an AI Einstein? That sounds like some demonic shit. I ain't gonna lie. That's like me asking you how far are we from a god robot or a Terminator. 'Cause
Maybe the very last
nah.
thing that these systems will be able to do, these LLMs will be able to do, is given the laws of physics as we understood them at the turn of the last century, invent general relativity
Yeah.
from that. So I think that's probably the terminal step. And then once it can do that, if it can do that, then there won't be much else to do as far
Yeah.
as humans are concerned. It's pretty extraordinary. I mean, particularly coming from a physics background in which progress is pretty slow, uh, to come to the AI field and see progress being so extraordinarily rapid.
And that's what's scary about, I guess, our way of understanding life. If you know physics, it's a lot of understanding to what and how we operate today. So like I don't know if you guys ever been doing, I guess, soldering or just trying to make some electrical things. Sometimes you just say fuck you physics when something doesn't work, right? Because the only thing that could explain certain bullshit is physics. For those who know, know. If you don't get it, then all right, cool. But that's like our thing. It's like, yo, fuck you physics. Because we don't understand why it happens the way it does. And now something else can understand why it happens faster than the way we can, which is kind of scary because like that's our way of living too. So at what point do we get replaced by what we make? You get what I mean? So it's like, man, we're dabbling with a lot of spirituality and religion, not AI and tech.
Day by day, week by week, year by year. Um, Looking at it, it certainly looks like these LLMs and these AI systems, in some sense, are just interpolators, but the level of abstraction at which they're interpolating keeps going up and up and up. And we keep sort of riding up that chain of abstractions. And then, presumably, from a sufficiently elevated point of view, the invention.
For those who don't know what interpolation means, because I know people just listen to big words, it means when you're used, like in music terms, you sample something, it's the same thing, just same track. You just sample the track. When you interpolate a track, you take a section of that sample and you make it into something unique that you could call it. So what AI is doing is taking sections of what we're using to train it off and making its own inferences. And it keeps interpolating, interpolating, interpolating until it gets to like Sentinel, I guess, because we won't understand how it gets to certain responses after a certain point.
Of general relativity from Newtonian physics is just interpolation at some sufficiently grandiose level of abstraction that perhaps tells us something about the nature of intelligence, human intelligence, as well as about these large language models. If you ask me how many years until we can do that, that is not totally clear. But um, in some sense, general relativity was the greatest leap that humanity ever made. And once we can do that, perhaps in 10 years, then we will have fully encompassed human intelligence. Will it have the same? Will it be of the same character as what Einstein did? Clearly, there are many disanalogies between human intelligence and these large language models, but I think at the right level of abstraction, it may be the same.
Do you think AI mathematicians, AI physicists will have advantages over humans just because they can, by default, think in terms of weird dimensions and manifolds in a way that doesn't natively come to humans?
Ah, um, I think maybe we need to back up to in what sense do humans do or don't think natively in high dimensions? Obviously, it's not our natural space.
Yeah.
There was a technology that was invented to think about these things, which was
Before he continues, this goes to remember the Rick and Morty episode where it's like his spaceship broke down or whatever the case was, and he had to go inside the generator, which was a whole different ecosystem and simulation powering his actual mechanical device. That's what he's getting at there, where it's like, okay, is there going to be a point where AI mathematicians replace humans or like at some point they become better? Better is subjective in that sense because most scientists possibly would like him will say we achieved human intelligence before artificial intelligence if you are making that statement because we're teaching it like we made it. So in a weird way, we when he says slow down and go back, it's him saying, well, let's not quickly downplay what we have accomplished and what we the groundwork we've put in over the course of time. And he's about to get into the technology and probably will describe how the technology helped them achieve human intelligence or some sort of human knowledge to even have the conscious ability to get to this point we are in today.
Notation, tensor notation, various other things that allows you to much using just even writing as Einstein did 100 years ago allows you to sort of naturally move between dimensions. And then you're thinking more about manipulating these mathematical objects than you are about thinking in higher dimensions. I don't think there's any sense, I mean, in which large language models naturally think in higher dimensions more than humans do. You could say, well, this large language models have billions of parameters. That's like a billion dimensional space. But you could say the same about the human brain, that it has all of these billions of parameters and is therefore billion dimensional. Whether that fact translates into thinking in billions of spatial dimensions, I don't really see that in the human, and I don't think that applies to an LLM either.
Yeah, I guess you could imagine that if you're just seeing like a
Told you.
million different problems that rely on doing this weird tensor math, then in the same way that maybe even a human it gets trained up through that to build better intuitions, the same thing would happen to AI. It just sees more problems and can develop.
He looks like a Indian Dan Blazerian, whatever his name is. Y'all know who I'm talking about. I want to do a side by side, but I don't. Yeah, we gonna do it. No,
Better
that's not.
representations of these kinds of weird geometries or something.
I think that's certainly true. That it is definitely seeing more examples than any of us will ever see in our life, and it is perhaps going to build more sophisticated representations than we have.
Yeah.
Often in the history of physics, a breakthrough is just how you think about it, what representation you do. It is sometimes jokingly said that Einstein's greatest contribution to physics was his a certain notation he invented called the Einstein summation convention, which allowed you to more easily express and think about these things in a more compact way that strips away some of the other things. Penrose, one of his great contributions was just writing down um, inventing a new notation for thinking about some of these space times and how they work that made certain other things clear. So clearly, coming up with the right representation has been an incredibly powerful tool in the history of physics, and many incredibly large developments, somewhat analogous to coming up with a new experimental technique in some of the more applied scientific domains. And yeah, one would hope that as these large language models get better, they come up with better representations, at least better representations for them that may not be the same as a good representation for us.
So there's an interesting question here. Clearly, these models know a lot, and that's evidenced by the fact that even professional physicists can ask and learn about fields that they're less familiar with. But this doesn't this raise the question of, we think these things are smart and getting smarter. If a human that is reasonably smart had memorized basically every single field and knew about the open problems, knew about the open problems in other fields and how they might connect to this field, knew about potential discrepancies and connections, what you might expect them to be able to do is not like Einstein level conceptual leaps, but there are a lot of things where it's just like, hey, magnesium correlates with this kind of phenomenon of the brain. This kind of phenomenon correlates with headaches. Therefore, maybe magnesium supplements cure headaches. These kinds of like basic connections you would. Anyways, does this suggest that LLMs are, as far as intelligence goes, even weaker than we might expect, given the fact that, given their overwhelming advantages in terms of knowledge, they're not able to already translate that into new discoveries?
Yes, they definitely have different strengths and weaknesses than humans. And obviously, one of their strengths is that they have read way more than any human will ever read in their entire life. I think maybe, again, the analogy with chess programs is a good one here. They will often consider way more possible positions, so some Monte Carlo research, than any human chess player ever would, and yet they're even at human level strength, they're if you fix human level strength, they're still doing way more search, so that their ability to evaluate is maybe not quite as natural as a human. So the same, I think, would be true of physics. If you had a human who had read as much and retained as much as they had, you might expect them to be even stronger.
Scott Aronson recently.
And I'm not gonna lie to you, this right here is why I don't trust Elon. I'm gonna end it right here because I want this to be a food for thought type of moment. Hitler. Yeah, that boy is making a guest appearance in 2025. Day 5. That's how you know this shit gonna get serious. Hitler, right? His mythology was to shoot his men up with methane or whatever drug it was. And he turned his men into superhumans. That's why niggas fear the Soviet Union, nigga. Them niggas was juiced up, boy. You was shooting them and they wasn't dying. They was superhumans, my nigga. And at that, this nigga Hitler was taking it himself. Yo, I don't know what it is, but I don't even need to know what it is with the way YouTube algorithm is. Moral of the story, Elon Musk got this Neuralink chip. This nigga is trying to have us unlock everything in our minds to be able to be 100%. Now, I'm not gonna lie to you, he's the man with the juice right now because all he gotta do is plug and play. He just need a nation that want him in the nation. Like Elon Musk gonna be the first tech mogul to have to go because if you don't, he gonna give out his work to someone else, and that work is gonna be worth I don't know, our country and nation. So let's put some perspective into this. Clearly Albert Einstein was one of the smartest in the world.
Or it was a year or so ago, he posted about the fact that the GPT-4 got like a B or an A minus or something on his intro to quantum computing class, which is definitely a higher grade than I got, and so I'm already below the waterline. um, but yeah, you teach a bunch of subjects, including GR at Stanford. I assume you've been querying these models with questions from these exams. How has their performance changed over time?
Yeah, I take an exam I gave years ago in my graduate general relativity class at Stanford and give it to these models, and it's pretty extraordinary. 3 years ago, zero. Uh, a year ago, they were doing pretty well, maybe a weak student, but in the distribution. And now they essentially ace the test. In fact, that I'm retiring that. That's just my own little how they're doing, and it's pretty strong. They it's maybe easy by the standard of graduate courses, but a graduate course
Yeah.
in general relativity, and they get pretty much everything right on the final exam. That's just in the last couple of months that these have been doing that.
What is required to ace a test? Obviously, like they probably have like read about all the general relativity textbooks, but I assume to ace a test, you like need something beyond that. Is there something you would characterize?
Physics problems compared to maths problems tend to have two components. One is to sort of take this word question and like turn it using your physics knowledge into a maths question,
Yeah.
and then solve the maths question. That tends to be the typical structure of these problems. So you need to be able to do both. The bit that's maybe only LLMs can do and wouldn't be so easy for other things is step one of that is like turning it into a maths problem.
Yeah.
I think if you ask them hard research problems, you certainly can come up with problems that they can't solve. That's for sure.
Yeah.
But it's pretty noticeable as we have tried to develop evaluations for these models that as recently as a couple of years ago, certainly 3 years ago, you just scrape from the internet any number of problems that are totally standard high school maths problems that they couldn't do. And now we need to hire PhDs in whatever field, and they come up with one great problem a day or something. The difficulty.
I think it's difficult to say how a LLM and everything is integrating, but it's always funny to see physics because physics is very spiritual in the sense that you either know it or you don't. And even if you do know it, is not always guaranteeing that you'll be right. There's always a possibility that physics may, fuck you over again. Um, I guess my question is, do you think we have the capability as humans to unlock 100% of our brain without AI? If we do, why are we building AI to, I guess, achieve everything that we'd like it to achieve without even trying to unlock even 20 to 30% of our brain so we can, I guess, contribute to the evolution of humans to a certain extent? I think it's a two-part question. Let me know what you think. I think Dwarkash Patel had great content. Uh, I'll see you later, y'all.